Next up is optimizing with partitioning and clustering. One of the ways you can optimize the tables in your data warehouse is to reduce the cost and amount of data read by partitioning your tables. For example, assume we have partitioned this table by the event date column. BigQuery will then change its internal storage so the dates are stored in separate shards. In a table partitioned by a date or timestamp column, each partition contains a single day of data. When the data is stored, BigQuery ensures that all the data in a block belongs to a single partition. A partition table maintains these properties across all operations that modify it: query jobs, DML statements, DDL statements, load jobs, and copy jobs. This requires BigQuery to maintain more metadata than a non-partition table. As the number of partitions increases, the amount of metadata overhead increases. Now, when you do a query with a where clause that looks for dates between January 3rd and 4th, BigQuery will have to read only 2/5 of the full dataset. This can lead to dramatic cost and time savings. You enable partitioning during the table creation process. This slide shows how to migrate an existing table to an ingestion time partition table. Using a destination table, it will cost you 1 table scan. As new records are added to the table, they will be put into the right partition. BigQuery creates new date-based partitions automatically with no need for additional maintenance. In addition, you can specify expiration time for data in the partitions. Partitioning can be set by ingestion time, on a date-time column, or based on a range of an integer column. Here, we are partitioning customer ID in the range 0 to 100 in increments of 10. Although more metadata must be maintained, by ensuring the data is partitioned globally, BigQuery can more accurately estimate the bytes processed by a query before you run it. This cost calculation provides an upper bound on the final cost of the query. A good practice is to require that queries always include the partition filter. Make sure that the partition field is isolated on the left side, because that's the only way that BigQuery can quickly discard unnecessary partitions. Clustering can improve the performance of certain types of queries, such as queries that use filter clauses and those that aggregate data. When data is written to a clustered table by a query or a load job, BigQuery sorts the data using the values in the clustering columns. These values are used to organize the data into multiple blocks in BigQuery storage. When you submit a query containing a clause that filters data based on the clustering columns, BigQuery uses the sorted blocks to eliminate scans of unnecessary data. Similarly, when you submit a query that aggregates data based on the values in the clustering columns, performance is improved because the sorted blocks co-locate rows with similar values. In this example, the table is partitioned by event date and clustered by user ID. Now, because the query looks for partitions in a specific range, only 2 of the 5 partitions are considered. Because the query looks for user ID in a specific range, BigQuery can jump to the row range and read only those rows for each of the columns needed. You set up clustering at table creation time. Here, we're creating the table, partitioning by event date, and clustering by user ID. We're also telling BigQuery to expire the partitions that are more than 3 days old. The columns you specify in the cluster are used to co-locate related data. When you cluster a table using multiple columns, the order of columns you specify is important. The order of the specified columns determines the sort order of the data. Over time, as more and more operations modify a table, the degree to which the data is sorted begins to weaken, and the data becomes only partially sorted. In a partially sorted table, queries that use the clustering columns may need to scan more blocks compared to a table that is fully sorted. You can recluster the data in the entire table by running a select star query that selects from and overwrites the table. But guess what? You actually don't need to do that anymore. The great news is that BigQuery now periodically does auto reclustering for you, so you don't need to worry about your clusters getting out of date as you get new data. Automatic reclustering is absolutely free and automatically happens in the background. You don't need to do anything additional to enable it. Currently, BigQuery supports clustering over a partition table. Table clustering is supported for both ingestion time partition tables and for tables partitioned on a date or timestamp column. Currently, clustering is not supported for non-partition tables. When you use clustering and partitioning together, the data can be partitioned by a date or timestamp column and then clustered on a different set of columns. In this case, data in each partition is clustered based on the values of the clustering columns. Partitioning provides a way to obtain accurate cost estimates for queries and guarantees improved cost and performance. Clustering provides additional cost and performance benefits in addition to the partitioning benefits.